Okay, good morning, dear students. In the last lecture, we just started unit number 5, that is DC to DC converter, also called as choppers. Okay, so this is a syllabus that we have already discussed in the last lecture. Then basic principle already we have seen. Classification, I'll just revise classifications in a short and then we will go for the next. So the classification is depends upon the output current and voltage. The choppers are classified as class A, class B, class C, class D, and class E. Right? So class A is also called as a one quadrant chopper. Class B is called as also called as a one quadrant chopper. Then class C two quadrant chopper, class D two quadrant chopper, and so on. Actually, I'll not ask you. Am I audible? Yes.
Yes,
Yes.
sir.
Yes,
Okay.
sir.
Okay. Okay.
Yes,
Sorry.
sir.
So, based on the output voltage, choppers are classified. In this particular, the output current and output voltage both are considered here based on output voltage. It is called as maybe classified as a step up, also called as a boost, step down, also called as a buck converter, and another is a step up down converter called as a buck boost converter. So these are the figures you can see here for chopper class A. The output voltage and current both is positive. So the characteristics lies in the first quadrant. So this is a chopper A. Chopper B in which the output voltage is positive but current is negative. In class C, also called as a two quadrant chopper, because the output voltage is either output voltage is positive but current is either positive or negative. It characteristics lies in first and second quadrant, so it is called as a two quadrant chopper. Class C is also called as a two quadrant chopper. Even class D is also called as a two quadrant chopper, in which the current is always positive, voltage may be either positive or negative. So this is called as a class D chopper, also called as a two quadrant chopper. And last one is a class E, or called as a four quadrant chopper. The output voltage may be either positive or negative. Similarly, current is either positive or negative. That's why it is called as a four quadrant chopper. Then the classification is given according to the circuit operation. Already we discussed first quadrant chopper. So output voltage and both must be positive, type A output voltage as well as current. Current is missing. Both must be positive. So this is nothing but type A chopper. Two quadrant chopper. The output voltage is positive and current can be positive or negative. That is a class C. Or the output current is positive and voltage can be positive or negative, called as a class D. So both are called as a two quadrant chopper, right? Then four quadrant chopper, the output voltage and current both can be positive or negative, right? That is a class E, nothing but a four quadrant chopper. So these are the types according to the circuit operation. Then last classification according to the commutation method. Already I told you that in SCR, if you are using SCR in DC circuits, so you require a commutation circuitry to turn off the SCR whenever you want, right? So commutation circuits, there are various types of commutator circuits. Few are given here: voltage commutated chopper, current commutated chopper, load commutated chopper, and impulse commutated choppers. So these are the four different methods, commutation methods. Even class A, class B, class C, these are also the commutation methods. So these are the four commutation methods used in a chopper circuit. So according to the commutation method, the choppers are also classified, right? So class A, maybe you can use voltage commutation. Even in class B, you can use voltage commutation or any type. But this is the classification according to the commutation method used, right? Even voltage commutated chopper, the name itself is called as a voltage commutated chopper. This is nothing but a this chopper may be either first quadrant, second quadrant, or four quadrant. right? Class A, class B, class C, class D, class C, anyone. But if you are using the voltage as a commutation method, then it is called as a voltage commutator chopper. So this is another classification. This classification, further classification, hard switch converter and soft switch converters. This is also we have seen already in the last lecture. Then methods of a control, we have to see in detail these methods. But in short, what is basically pulse width modulation and what is a variable frequency control, that we have already learned with the help of these two figures, right? So in this first figure, the T on is changed, but the total T is constant. You can see here in first and second. So T on is a small, T off is a bigger. Here T on is bigger, T off is a smaller, but total T is a constant. So that is called as a pulse width modulation control, in which T on is changing, but the total T remains constant. And in second one, that is called variable frequency control, in which either T on or T off must be constant, but frequency is changing. So in above figure, T on is constant for both the waveforms, this one and second one. T on is a constant, but you can check the time T. Time T is a different. So frequency is a different. Then already we have seen these step down chopper, also called as a buck converter. So this is a something bigger diagram for step down chopper, right? So the working of this chopper already I explained in the last lecture, but again I'll explain in a short. So in this particular chopper circuit, there is a one switch which is connected in series with the supply and load, right? So this element is itself is called as a chopping element, or you can say chopper, okay, or maybe a power switch. You can use any power switch, maybe either power BJT, power MOSFET, IGBT, SCR, JTO, anyone. Uh, Keep in mind, the SCRs are used for high power applications, and other devices you can use for low and medium power applications. With these switches, there is, there is always a requirement of triggering circuit and protection circuit, right? So that is not shown here. Even commutation is also required if you are using SCR as a device or as a switch, okay? So that figures, that circuit diagram is not shown here, only switch is shown here. Even SCR is also not shown. In place of SCR, a symbol of switch is shown. So we can use any switch. That's why the symbol of switch is used in a figure. Now, in this figure, there is a one inductor, then traveling diode, and one switch and load, right? So whenever the switch is off, if switch is off, initial condition, no current flow through the load. But if switch is on, then current start to flow from EDC plus, then switch, then L. When it current flows, that time the voltage or charge stored, or L start to store the charge with the polarity positive this side and negative this side. Then current flows through R, that is a load, then back to the ADC minus, right? This is a flow of charge, flow of current, okay, during switch is on. Whenever the switch is off, if switch is off, what happens? Immediately the polarity across the charge, stored charge, get reversed. So it will changes the polarity like as shown in figure. So this side is positive with respect to this side. So inductors start to release the energy through the load, right? Then this diode is in forward bias condition because the cathode is negative with respect to anode. So diode is turns on, current flows through diode back to the inductor, then load, then again back to the diode, and so on. So your current is constant, or you can say continuous, but voltage is discontinuous. That is shown here in output waveform. Here the switch is on, that time the output voltage equal to EDC, right? So output voltage equal to EDC, inductor store the charges, so the current increases like this, right? At this instant, when switch is off, then inductor start to release the energy through the load and EDC. So current decreases, right? But still it's a positive on and continuous. Okay, discontinuous current nahi hai, current is continuous. Voltage becomes zero, but current is still continuous. So again at instant this one again switch is on and so on. So current across the inductor increases, releases the energy, again store the energy, release the energy, store the energy. So this part is a energy stored across inductor. So that is increasing as your time increases. And at this instant, when switch is off, inductor start to release the energy. So current through inductor decreases. Again at this instant, when you turn on the switch, again inductor start to store the energy and so on, right? So current direction is positive continuously and current is continuous and voltage is like this. The output voltage is depends upon the duty cycle that we will see here. Total E0 equal to EDC into T on by T on plus T off. T on plus T off is nothing but your total T. T on by T nothing but your duty cycle. So output voltage is equal to EDC into alpha. Alpha is denoted by duty cycle. So see here T equal to T on plus T off. This is called chopping period. T on by T, alpha equal to T on by T, alpha nothing but duty cycle. So E0 equal to EDC T on by T, E0 equal to EDC into alpha. So this is a output equation for the step down chopper, right? Even you can put here E0 equal to T on by T into EDC. So 1 by T nothing but F. So T on into F into EDC. F is a chopping frequency. Okay, F is a chopping frequency. So output voltage is E0 equal to EDC into alpha. That is most important. Now average value of a load current, that is I0 equal to E0 by R. E0 nothing but alpha into EDC, alpha into EDC by R, and the effective RMS value of output voltage is given as, that is EDC into alpha, that is EDC square into T on by T under root. So it is equal to EDC by under root of alpha. EO RMS equal to EDC into under root of alpha. This is effective RMS value of output voltage. What is the meaning of this? The because of inductor and because of the switching, there will be some ripple components at the output of a chopper, because basically chopper is a DC-DC converter, but still because of this switching and inductor effect, some AC voltage will be appear across the load, and that nothing but the effective RMS value of output voltage, and it is equal to EDC into under root of alpha, right? One problem is given on this uh, because in examination uh, there will be a problem on a chopper, very few chances uh, for the problems, but if the question will be asked, that is maybe problem, so definitely it will be asked on a chopper. So I have given one example here from above equation. A DC chopper circuit connected to the 100-volt DC source, so EDC is given. Then source supplies an inductive load of 40 millihenry in series with the resistive resistance of 5 ohm. So R is given. A freewheeling diode is placed across the load. The load current varies between 10 ampere to 12 ampere. Determine the time ratio of a chopper. So you have to calculate the T on by T off. That is called time ratio of a chopper. So I will share the PDF of MD Singh and Khan Chandani, so in which the problem is given with its answer, right? So you can refer this one. So this is about the step down chopper. Next one is step up chopper. Now, I just want to ask you one question. If suppose if you understand the working of step down chopper, then we will go for the step up chopper. Otherwise, I'll repeat the step down chopper again, because the step up chopper is slightly different, and again there will be a step up and down chopper, then two quadrant chopper, and then four quadrant chopper. So to understand the working of remaining chopper circuits, you have to understand the working of step down chopper first, right? So again, I'll ask you if any doubt in step down chopper, you can ask me. Otherwise, I will go for the next, that is called step up chopper. Okay, those are present. If possible, just look at the figure and try to explain the working, how it works. If you understand the working of step down chopper in a proper way, then definitely you are able to explain a step up chopper. It is quite simple. Yes, anyone? This is a step up chopper. How it works? See, the place of switch is changed, the place of diode is changed, the place of inductor is also changed. So how it works? Anyone try to explain? Yes? Anyone from the class? Very poor response. Even zero response, you can say. It means that you have not understood the working of step down chopper. Otherwise, you are definitely able to explain the working of step up chopper. Anyone can unmute yourself and explain if possible. At least try to karo. How it works? This is a step up chopper. It means that the output voltage is equal to or greater than EDC. How it is possible? Right? It is not an amplifier, but still the output voltage E0 is equal to or greater than EDC. How we get the output voltage greater than EDC? Because this is not an amplifier circuit, but still the output voltage is greater than input voltage. How it is possible? Yes, anyone? No. Good. Uh, Participants, Santosh Andale. Santosh, unmute.
Yes, sir.
Can you explain the working of this step up chopper? Anything in the circuit. Not necessary ki your answer must be perfect or correct. It is not expected.
Sir, can I explain?
Why not?
When chopper is on, sorry,
no problem. Chopper is on. Switch or chopper, switch itself is called as a chopper. So no problem.
Current pass.
When chopper is on, current passes from EDC, then switch and back to the EDC, right? Okay. Then that time output voltage. That time the output voltage is equal to 0, right? Okay. When switch is on, current flows through this L, the chopper back to the EDC. So output voltage is equal to 0. Yes.
Hello. Sir, step up chopper working ना? आवाज नहीं हो रहा है सर मला. नेटवर्क प्रॉब्लेम आहे थोडा.
बरं ठीक, काय प्रॉब्लेम नाही. कावेरी तू सांगतेस का?
when switch is
Period or
off.
switch off period.
Hello, hello.
Hello.
हाँ सांग.
If switch is not closed, then current pass through whole circuit. Then load is
Like
in
this.
some value.
Okay, okay, okay.
Hi.
Okay, okay. Very good for try. And तू तुझ्या मनाने म्हटलीस त्याबद्दलही खूप आनंद वाटला. कोणीतरी म्हणतंय की मी सांगू का, कोणीतरी प्रयत्न करतंय, याचा खूप आनंद होतोय. Okay, so right now I'll explain you. Kaveri already explained, and which is very close, or maybe you can say correct, right? So I'll just add something, some points into the working of this circuit. What happens here, during the switch is on, when the switch or a chopper is on, what happens, the current start to flow through L, through the chopper back to the ADC minus. So plus ADC plus L, chopper, then ADC minus, right? At that time the inductor store the energy with this polarity, positive and negative, as shown in figure. The polarity of a stored charge, as shown in figure, it stores the energy in its magnetic field, right? The stored charge is equal to the EDC, or maybe less than of EDC, right? So inductor store the energy in its magnetic field. When switch is off, what happens? This EDC, the polarity of this stored charge get reversed. So this become a positive and this become a negative when switch is off, right? Now this becomes a battery, right? This is a stored charge across inductor, okay? And then another battery that is called EDC connected in a series. So what happens? The EDC, this voltage is called EDC, right? And this is the voltage across inductor, L di by dt, right? So addition of this voltage plus this voltage, the total voltage or maybe a current will flow through the diode and through the load, so that the E0 is equal to twice EDC, or maybe a definitely greater than of EDC, right? During on switch, inductor store the energy, and during off switch, inductor release the energy, right? Inductor energy plus EDC, that total energy delivered to the load, so that the output voltage is equal to the twice EDC, or it is definitely greater than of EDC, right? So EDC E0 equal to greater than of EDC. So the circuit is called as a step up chopper, right? Very easy, because when switch is on, that time the current flow through the L switch and so on, right? In this particular period, the inductor stored the energy in its magnetic field. The polarity of a stored charge as shown in figure, positive and negative. But when switch is off, the polarity of a stored charge get reversed, like shown in figure, right? And then what happens? These two batteries, the voltage across inductor and this EDC comes into the in series. This is a voltage across inductor and this is the EDC. So both battery voltages are connected in series. So if voltages are connected in series, there will be an addition of these two voltages, right? So the voltage stored or energy stored across inductor gets added with the EDC, and the total voltage will be delivered to the load. So E0 is greater than EDC. This is output voltage is greater than or equal to EDC, right? So this is the working of a step up chopper. See the chopper configuration. Step down chopper is capable of giving maximum voltage that is slightly smaller than input DC voltage. So E0 is less than EDC. However, the chopper can also be used to produce higher voltage at the input, at higher than input voltage, that is E0 is greater than equal to EDC. So when chopper is on, the inductor L is connected to the supply EDC, and inductor store the energy during on period, that is T on. When the chopper is off, the inductor current is forced to flow through the diode and load for a period called as a T off. As a result, or maybe a current tends to decrease, polarity of EMF induced in inductor is reversed to that of shown in figure, and as a result, voltage across the load is equal to E0 equal to EDC plus LDIS by dt. So that is the inductor voltage add to the source voltage. This is important. The inductor voltage adds to the source voltage to force the inductor current into the load. In this manner, the energy stored in the inductor is released to the load. Here, higher value of inductance. This is most important again. Higher value of inductance L is preferred to getting lesser ripple, because as already I told you, if the inductor and switching action which produces some ripple components, that is AC components, and that already we have seen, that is called as effective RMS value of output voltage, and that is calculated with the help of EDC into root alpha, right? So definitely the use of inductance and switching action produces some AC voltage, right, at the output of a DC chopper. Basically, the output of this chopper must be variable DC, but because of this inductor and switching action, some AC components are still present. So to avoid the AC components, we have to use higher value of inductor. Okay. Then during the T on or time on, when chopper is on, the energy input to the inductor from the source is given by EDC into IS into T on. So total energy that is given to the inductor is equal to EDC into IS into T on. Then equation above, an above equation is based on the assumption that the source current is free from ripple. Source current is free from ripple, right? It means that we are using high value of inductance. So we assume that the ripple current is zero. Now, during the time T off, when chopper is off, energy released by the inductor is equal to E0 minus EDC into IS into T off, right? So total output voltage minus EDC is nothing but the energy stored by inductor, right? Total output voltage is E0. We assume that the battery voltage is 10 volt, right? So what will be the inductor voltage? That is output voltage minus 10 volt into IS into T off. That is the energy released by the inductor. Now, considering the system to be lossless, we consider that the inductor is very high value. There is a no ripple voltage, and is a steady state. These two energies will be equal. So E0 or Wi is equal to W0. So Wi nothing but the EDC into IS into T on. This is Wi, and this is WO. Uh, Inductor store the energy, that is equal to Wi, and release the energy by inductor is W0. If we consider that the system is lossless, then definitely these two energies are equal, right? Because whatever energy is stored by inductor releases that total energy. Okay, so EDC equal to IS into T on, that is Wi, and E0 minus EDC into IS into T off, that is W0. So E0 equal to EDC T on plus T off by T off. Okay, then E0 equal to EDC T divided by T minus T on. Okay, T on plus T off is nothing but a T, right? And T off nothing but T minus T on. T on plus T off is nothing but a T, and T off is replaced with a T minus T on. Total T minus T on, nothing but a T off. So E0 equal to EDC 1 divided by, so T from बाहर काढतो, so T by T minus T on by T. So T on by T nothing but your alpha. So total E0 equal to EDC divided by 1 minus alpha. E0 equal to EDC divided by 1 minus alpha, right? If alpha equal to 0, E0 equal to EDC. And if alpha equal to 1, E0 equal to infinite. You can check here. Just put the alpha equal to 1. When alpha is equal to 1, when t on equal to t, right? When t on equal to t, then alpha equal to 1. If you put alpha equal to 1, then E0 equal to infinite. EDC divided by 0, right? 1 minus 1 is equal to 0. So you will get here, if you change the alpha, you will get a variable voltage, right? You will get a variable voltage. That is from EDC to infinite. EDC to infinite. V0 equal to EDC to infinite. If alpha is equal to 0 to 1, if you change the alpha between 0 to 1, the output voltage is equal to EDC to infinite, right? So you will get a variable voltage by simply changing alpha, right? So hence the variation of a duty cycle alpha in the range of 0 to 1, the output voltage E0 vary in the range of EDC to infinite. This principle of step-up chopper can be employed for regenerative braking. Regenerative braking of a DC motor. This type of braking is used in a railway, right? That is to control the speed of motor for braking of railway or maybe a DC motors in a railway. Again, I have given one problem on this step down chopper. Step up chopper is used to deliver load of 500 volt, right? So output voltage is 500 volt, that is E0 from 220 volt DC source. So ADC is 220 volt. If the blocking period, that is off period of a thyristor is 80 microsecond, compute the required pulse width. It means you have to find out the T off. Okay, so T off is known, then V0 is known, ADC is known. You have to just find out the T on, right? T on तुम्हाला काढायचा आहे. Then next one is step up down chopper. Now again a small change in a figure, right? So switch again connected in series. Now L is connected parallel to the load and diode is in reverse bias condition. Okay, so tell me how it works. Now again step up and down. So this circuit will work as a step down as well as step up chopper. So how it works? Anyone try to explain? Unmute yourself and explain. Before that, you have to give your attendance in a chat box. Give your attendance in a chat box and then unmute yourself, anyone, and try to explain the working of this circuit called as a step up down chopper. Step up down chopper. Pallavi. Pallavi Chauhan. Is there any problem? Any difficulty, any doubt? You can unmute and ask.
No, sir.
Yes? Okay. Anyone from the class if try to explain this step up down chopper if possible. I'm not expecting again a perfect or correct answer, so I just want your try, right? Your try to explain that I just want from you. So try to explain how this circuit will work. I'm not asking about how it will work as a step down and how it work as a step up. I'm not asking about that. That I will explain you later on, but at least the working of this circuit, how it works. Okay, last 1 minute is remaining. I'll explain you in the next, but still 1 minute is there, so I'll explain you. If the switch is on, what happens? If the switch is on, then the current flows through this particular switch, right? That time the diode is in reverse bias condition, so current flows in this direction, right? And inductor store the energy with the polarity upper positive with the lower negative terminal, right? This is a on time, so output voltage is equal to 0 during this particular time. Now, when switch is off, then the polarity of this stored in energy is reverse, that is as shown in figure, upper terminal negative, lower terminal positive, then current start to flow through the load and through the diode. This is a freewheeling diode, right? So this is a working. I'll explain you how it works as a step down and step up in the next lecture. Thank you. Thank you all.